In physics, one of the classic exercises is calculating distance based on how fast something is going and how long it's moving, and there's formulas for that. Fundamental to understanding how the rate problems work, that is, distance equals velocity times time. It's necessary to get an understanding of this concept of initial distance and final distance. So that can be really relatively easily understood. And if I were to tell you that right now I'm 6 miles from my house, that would be my initial distance. I'm 6 miles from my house. And then if I were to tell you how fast I were traveling, and which direction I was traveling, and how long I traveled, then you can figure out how far I would be from my house after a certain amount of time, right? So that makes sense. So the final distance is going to be however far you travel added to the initial distance. So you might say the initial distance is what I say, 6 miles, and if I change my distance by 2 miles and I'm going further away, the final distance is going to be 8 miles. If I change my distance by 2 miles and I'm getting closer, then the final distance is going to be 4 miles. So we can say that mathematically the final distance is the initial distance plus or minus the change in distance. So as a formula, we would write all of these are distances, like change in distance, final distance, initial distance, and all of those things. So we would write those with subscripts. And so we would say that the final distance would be d sub f, d with a subscript f. Initial distance would be d with a subscript I. And you could do change of distance as delta d for change, delta d for change in distance. So that would look like this. So final distance, d sub f equals d sub I plus delta d, change in distance. Later on we'll learn about the change in distance formula. So we'll have that, how do you know what the change in distance is? And that's pretty simple too.